Hello my friends, today we're going to take a look at kind of the opposite of what the last video is about. The last video is about taking the integral of e. Today we're going to take a look at the opposite of that, which would be the derivative of e. If you've got y equals e to the x and you want to try and figure out what the derivative is going to be, you start off by taking ln of both sides. Basically I just want to do that because I have no way of dealing with variables in the exponent. Over on the right, ln of e just cancel, and you're left with just equals x. If we use implicit differentiation, which is required here because my y is mixed up in my math, my derivative of ln of y is just 1 over y, and then I follow that with y prime. X is just x, so my y prime is going to equal, oops, that's not true. The derivative of x is just 1, which means my y prime is just going to equal y, and y was e to the x. So surprise, surprise, the derivative of e to the x is e to the x. It should not be a surprise because in the last video we found out that the integral of e to the x was e to the x. So it stands to reason it works both ways. So here's our general rule, e to the u, its derivative is e to the u times du dx. So just like in the last video, we had to sometimes replace the exponent with a u to try and use the substitution rule. In this video, we're sometimes going to have to replace the exponent with a u to use the chain rule, because that's kind of the complement of the substitution rule in the world of derivatives. So a nice easy problem to get us rolling. Y equals 2e to the x. Its derivative is just going to be 2e to the x. I don't need to use a chain rule here because it's just a simple x in the exponent. If there was 3x up there or x squared or trig or anything, I would have to do a chain rule. But just a plain simple x is plain simple answer. Alright, so this one looks a little bit more robust. My y prime is going to equal e to the stuff is just e to the stuff times stuff, or the derivative of stuff. And sine has no e in it at all, so it's very old school. The derivative of negative sine is going to be negative cosine of stuff times the derivative of stuff. And that's my answer. So really the hard part of this whole section is just keeping your brain straight as to which way you're going. Are you taking derivatives? Are you taking integrals? Should the derivative of sine be cosine, or should the antiderivative of sine be negative cosine? It's those little nuances that really cause a whole lot of trouble. The main idea is not that bad. Alright, so here we see another example. So my y prime is going to equal, because I've got all these parentheses, I should really work, ooh, wait, I see something interesting. ln of e just cancels each other out. So this original problem can be simplified into sine of 4e to the 2x, just to save us one level of chain. So now instead of having to deal with a 3-chain problem, we get a 2-chain. So the derivative of sine is going to be cosine of stuff times, now I have to do the derivative of stuff. The derivative of 4e to the stuff is 4e to the stuff times the derivative of that stuff. And that's my answer. Alright, so this one's kind of a trick question. I see this x e squared combo, and it kind of looks like it should be a product rule because I have an x times an e. However, note the slight change. My e just has an exponent of 2. It does not have an exponent that has a variable in it. So e to the 2 is really just a number, somewhere around 9. So this is pretty much just a glorified 9x. The derivative of 9x would just be 9. And now I get the second piece. The second piece is just a copy, and then times the derivative of the exponent, which would be 4. And that's my answer. If we had to go y double prime, the derivative of this e squared would just be 0, because that e squared is a constant. Alright, so here we get 3e to the stuff. Its derivative is going to be 3e to the stuff times 2x. And here I get this x times e to the x this time. So this is actually going to require the product rule. So remember, our product rule is going to be u prime v plus uv prime. My u in this problem is x, and my u prime is 1. I don't really like my u to be x for the substitution rule, but for product or quotient, it's absolutely fair game. My v is e to the x, and my v prime is just simply e to the x. It's the exact same thing. So my u prime was 1 times e to the x, My u is x times e to the x. And that whole list is my answer. Absolute minimum of the function. We're going way, way back on this one. This is a nice opportunity to remind you of things you're going to need for the final. All the optimization stuff and related rate stuff that we did earlier in the corner is still on the final. So it's a good idea to keep this stuff in mind. To find the absolute minimum, essentially what we want to do is we want to take the derivative and set it equal to 0. So I'll take the derivative of this equation, e to the 4x times 4, and then minus 1. Setting that equal to 0 is not super easy, but we still know how. I add 1 over to the other side, and then I would divide by 4. And this is where we hit the crossroad. This is not an obvious move. If this was a quadratic, I would know how to solve it. If it was trig, I have inverse trig. To get past an e, I need some ln's. Remember, e to the power equals number is the same thing as ln of this side equals 4x. ln of 1/4 is a decimal. I could get that on my calculator and then divide that answer by 4. And that's my x value. Once I've got my x value, it's probably a smart idea to throw it on a number line, plot it somewhere, and then check on either side to make sure that I'm getting that minus plus relationship. And this is my y prime graph. Make sure I'm getting that minus plus relationship to show that I do indeed have a minimum, and I didn't pick up something wrong along the way. All right, so for our last one, we're going to do a little bit of a word problem. $100 compound continuously, blah, 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 equation. So I know that my v equals 100 e to the 0.04 t. How fast is the value of the money changing after 5 years? Now, it is important to note at this juncture that v of t is not a velocity statement. It's kind of like the value at time t. So if I want to know how fast it's changing, essentially what I want to know is v prime of 5. Because fast is talking about rate of change. That's derivative. So I can take the derivative of this statement, which is basically just going to be 100 e to the 0.04 t times 0.04. 0.04 times 100 is just going to be 4 e to the 0.04 t. I want that t to be 5 because that's the year I'm talking about, and then that's going to give me my answer. 0.04 times 5 is a number, e to that power is a number, times 4 is a number, and that's my rate of change. And that would basically be dollars per year at that moment. All right, so we got a little taste of E. Big thing for you to do is to go back and remember your product rule, remember your quotient rule, remember your chain rule, all those derivative rules we haven't used for a little while. They're all going to show up in these E problems. Your job is to decide which rule is most appropriate for the problem to figure out what the derivative is.